November 12th, 1942, Richmond, California. A welder named Rose Kramer stood before a disciplinary board at Permanente Metals Corporation, accused of violating every safety protocol the maritime industry had established over 3 centuries. Her crime was not theft, not sabotage, not insubordination. Her crime was that she had developed a welding technique so unconventional, so seemingly reckless, that traditional shipbuilders demanded her immediate termination. Yet the ships she touched were launching faster than anyone thought possible, and the mathematics of war would not wait for proper procedures. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The woman standing before that board represented something the maritime establishment could not comprehend. She was not a master craftsman. She had never served an apprenticeship. 6 weeks earlier, Rose Kramer had been a seamstress in a San Francisco garment factory, stitching dresses for $12 a week. Now she was wielding industrial welding equipment, joining steel plates that would carry ammunition across submarine-infested waters to fighting men on foreign shores. Everything about her presence in that shipyard violated tradition. Everything about her technique violated protocol, and everything about her results defied explanation. The journey to that disciplinary hearing had begun 9 months earlier, in February 1942, when Rose answered a newspaper advertisement that promised high wages and urgent national service. The advertisement did not mention that she would be doing work that no woman had been permitted to attempt in the entire history of American shipbuilding. It did not mention that she would be trained in techniques that the industry considered experimental at best and dangerous at worst. It mentioned only that America needed workers, that the pay was good, and that training would be provided. Rose arrived at the Richmond shipyard on a Monday morning in late February, one of 300 applicants reporting for the week's training session. The group included former mechanics and farmers, yes, but also librarians, school teachers, grocery clerks, and housewives. Traditional shipyards would have rejected 95% of these applicants as fundamentally unsuitable. Henry Kaiser's operation accepted them all. The only requirements were willingness to work and ability to follow instructions. The training program that Rose entered bore no resemblance to the apprenticeship systems that had governed skilled trades for generations. Traditional welders spent 4 years learning comprehensive techniques under master craftsmen who had themselves spent decades perfecting their art. Rose's instructor, a man named Jack Morrison, who had been welding pipeline joints in Nevada just 3 months earlier, promised to teach her everything she needed to know in 10 days. The traditional maritime establishment considered this timeline absurd. You could not transform a seamstress into a shipbuilder in 10 days. The accumulated wisdom of centuries said so. Jack Morrison did not care what accumulated wisdom said. He had examined the welding requirements for Liberty ship construction and recognized something the traditionalists refused to see. The ships did not require master craftsmen capable of welding anything under any conditions. The ships required specialized workers capable of welding specific joints in specific positions repeatedly and reliably. Rose would not learn to weld everything. She would learn to weld vertical seams on bulkhead plates, a task she would perform thousands of times in the coming months. The first day of training, Morrison demonstrated the technique on a practice piece. The electric arc welding torch, powered by cables carrying enormous current, created temperatures exceeding 3,000 degrees Fahrenheit. The arc melted the edges of steel plates while simultaneously melting a consumable electrode rod, fusing the metals together in a bead of molten steel that cooled into a joint stronger than the surrounding material. Traditional riveting had required heating metal pins to glowing temperature, inserting them through aligned holes, and hammering both ends flat while the metal remained hot. A skilled riveting crew could install perhaps 100 rivets in a 10-hour shift. Rose would learn to create welded joints at 10 times that speed. Morrison's instruction focused on 3 essential elements: maintaining the correct arc length between electrode and workpiece, moving the torch at consistent speed, and achieving proper penetration without burning through the plate. Everything else, all the comprehensive knowledge that traditional welders accumulated over years, was unnecessary for the specific task Rose would perform. She practiced on scrap plates for 8 hours daily, creating vertical seams again and again until her muscles learned the precise motions required. By the 5th day, Rose could create acceptable vertical seams consistently. By the 8th day, her work passed quality inspection without rejection. On the 10th day, she received her certification and her assignment to building way number 4, where hull number 73 was beginning assembly. She was now officially a shipyard welder, certified to perform work that would help determine whether America won or lost the war. The traditional shipbuilders who learned of her 10-day training considered it a scandal. Rose considered it an opportunity. The reality of shipyard work proved far more demanding than training had suggested. Building way number 4 stretched 500 feet long, an open-air construction site where wind, rain, and winter cold made every task more difficult. The hull section Rose joined her first day was a massive bulkhead assembly, 15 feet tall and 20 feet wide, supported by scaffolding while welders worked from both sides simultaneously. Rose's assignment was straightforward: weld the vertical seams where individual plates had been joined by tack welds during initial assembly. Make the joints watertight and strong enough to withstand North Atlantic storms. Do not burn through. Do not create gaps. Do not fall behind schedule. The work was brutal. Rose welded from platforms 20 feet above the ground, the torch heavy in her hands, the protective hood limiting her vision to the small area around the arc. The intense light from multiple welders working simultaneously created shadows and glare that made judging bead quality difficult. The smoke and fumes, despite ventilation systems, burned her throat and made her eyes water. By the end of her first full shift, every muscle ached. By the end of her first week, she understood why traditional shipbuilders had considered their craft so demanding that only men could perform it. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Yet Rose also recognized something that the traditionalists had missed. The physical demands of the work were real, but they were not insurmountable. Women possessed less upper body strength than men on average, yes, but welding did not primarily require brute force. It required steady hands, patient attention to detail, and willingness to perform the same precise motion thousands of times without deviation. These were skills Rose had developed during 15 years of garment work, stitching seams in dresses and coats with mechanical precision. The transition from fabric to steel required different tools, but the fundamental discipline was identical. By her 3rd week in the shipyard, Rose had discovered something else. The official welding procedures, the techniques taught in training and specified in maritime, commission guidelines, were not actually optimal for the specific work she was doing. The guidelines had been developed for general shipbuilding applications and assumed welders would encounter varying conditions and requirements. But Rose was not encountering varying conditions. She was welding the same vertical seams on the same type of bulkhead plates, hour after hour, day after day. The official procedure required frequent stops to change electrode rods and check bead quality. Rose began experimenting with longer, continuous runs that maintained consistent heat in the joint. The traditional approach called for multiple passes over each seam, building up the weld bead gradually to ensure proper penetration and strength. Rose discovered that on the specific plates she was joining, a single heavy pass with higher current achieved better penetration and created stronger joints in half the time. The official specifications required grinding and cleaning between passes to remove slag and impurities. Rose found that her single-pass technique eliminated most grinding while producing cleaner joints that passed inspection more reliably. The modifications Rose developed were subtle, barely noticeable to casual observers, but the results were unmistakable. While other welders on her crew completed perhaps 30 vertical seams during a 10-hour shift, Rose was completing 50. While others faced frequent rejections during quality inspection, Rose's work passed consistently. By the end of her first month, she had become the most productive welder on building way number 4, and her supervisor had begun assigning her the most critical seams, where structural integrity was essential. What Rose did not realize was that her modifications violated multiple official protocols. The Maritime Commission specifications, developed in consultation with traditional shipbuilders and naval architects, required the multi-pass approach specifically to ensure quality. Single-pass welding was considered acceptable only for non-structural applications, where joint strength was less critical. Rose's heavy single-pass technique on structural bulkheads represented exactly the kind of corner cutting that traditional builders feared would result from employing untrained workers. The crisis emerged in early May, when a Maritime Commission inspector conducting routine quality audits observed Rose's technique and immediately filed a violation report. The inspector, a man named Gerald Hendricks, who had spent 30 years in traditional shipyards before joining the commission, watched Rose complete 3 vertical seams in the time he expected 1 seam to require. His report, preserved in National Archives records, combined technical concern with barely concealed outrage at what he considered industrial negligence. Welder Identification Number 473R is performing single-pass welding on structural bulkhead seams in direct violation of specification MV-41B, which explicitly requires minimum 2-pass technique for all structural applications. The welder is using excessive amperage that risks burn-through and is eliminating specified cleaning operations between passes. This technique may produce superficially acceptable beads while creating internal defects that will not appear until the vessel encounters heavy seas. I recommend immediate suspension pending investigation and potential termination to prevent unsafe practices from spreading to other workers. The report triggered the disciplinary hearing that convened on May 15th. Rose sat before a panel consisting of her shift supervisor, the yard safety officer, and a representative from the Maritime Commission. The charges were presented formally: violation of approved welding specifications, deviation from certified training procedures, and performing unauthorized modifications to established techniques. Each charge carried potential termination. In wartime America, losing a shipyard job meant losing draft deferment. For Rose, termination meant her husband, already classified 1A, would be inducted within weeks. The safety officer presented the case methodically. The specifications existed for sound engineering reasons. Single-pass welding had been rejected for structural applications because it could not reliably achieve the penetration depth required for joints that would experience severe stress. The multi-pass approach, while slower, ensured that each layer fused properly with the previous layer and with the base metal. Rose's technique, however impressive in speed, represented exactly the kind of dangerous shortcut that would result in ships breaking apart at sea. Then Rose's supervisor, a man named Thomas Chen, who had been a construction foreman before joining Kaiser's operation, requested permission to present evidence. He produced the quality inspection records for building way number 4, covering the previous 6 weeks. The records showed rejection rates for each welder on the crew. The yard average for bulkhead seam rejections was running approximately 8%, meaning 8 out of every 100 seams failed initial inspection and required rework. Rose's rejection rate over 6 weeks was 1.2%. Her seams were not merely acceptable, they were the highest quality work being produced in the entire yard. Chen then presented something more dramatic. He had arranged for destructive testing of weld samples, cutting sections from completed bulkheads and subjecting them to stress analysis. Traditional multi-pass welds showed penetration depths averaging 62% of plate thickness, adequate for specifications, but not exceptional. Rose's single-pass heavy welds showed penetration averaging 87%, significantly exceeding requirements. The heavy current she used, which Inspector Hendricks considered dangerous, was actually creating deeper fusion and stronger joints than the approved technique achieved. The Maritime Commission representative, clearly uncomfortable with evidence that contradicted established wisdom, argued that Rose's results might be anomalous. Perhaps she had simply been fortunate. Perhaps the sample size was too small. Perhaps other factors explained the superior performance. Chen had anticipated this objection. He had spent the previous week training 3 other welders in Rose's technique under controlled conditions. All 3 had achieved similar results: higher productivity, lower rejection rates, and stronger joints than the approved multi-pass method produced. The hearing lasted 4 hours. The decision took 10 minutes of private deliberation. Rose was not only cleared of all charges, but was promoted to lead welder with responsibility for training others in her technique. The Maritime Commission representative filed a dissenting report, but the yard had already made its choice. Results mattered more than protocols. Ships that launched mattered more than procedures that delayed launching. The transformation of Rose Kramer from accused violator to celebrated innovator occurred within days. Her technique, now officially designated the Kramer method in yard documentation, became required training for all new welders assigned to bulkhead work. The productivity improvements rippled through the facility immediately. Building way number 4, which had been completing hull sections at the yard average pace, became the fastest operation in Richmond. Ships that had been projected to require 70 days from keel laying to launch were being completed in 62 days, with the reduction coming almost entirely from faster welding of structural components. But the deeper significance of Rose's vindication extended beyond productivity statistics. The Maritime Commission inspector, who had demanded her termination, represented the voice of traditional authority, the accumulated wisdom of generations of shipbuilders who knew from experience what worked and what did not. Rose represented something the establishment could not acknowledge, the possibility that accumulated wisdom might be wrong, that traditions might be limitations rather than truths, and that untrained workers, unburdened by conventional thinking, might discover better approaches than master craftsmen had developed over lifetimes. The psychological impact on Richmond's workforce proved as significant as the technical improvements. Thousands of workers, most of whom had never imagined themselves capable of industrial work, watched a former seamstress not merely succeed but innovate in a field dominated by male craft traditions. If Rose Kramer could transform shipbuilding technique in 6 weeks, what else might be possible? What other supposedly unbreakable rules might actually be breakable? What other expert proclamations of impossibility might actually be invitations to innovation? By June 1942, the Kramer method had spread beyond Richmond. Kaiser's other yards in Portland, Vancouver, and Swan Island adopted the technique after reviewing the test results. Traditional shipyards building Liberty ships under Maritime Commission contracts sent representatives to observe and reluctantly acknowledged that the faster single-pass approach produced superior results on the specific application for which Rose had developed it. The Maritime Commission, faced with undeniable evidence, revised specification MV-41B to permit single-pass welding on bulkhead seams when performed by certified welders using approved parameters. The revision represented more than a technical update to welding specifications. It represented the Commission's forced acknowledgement that innovation could come from unexpected sources, that untrained workers could improve on expert techniques, and that wartime necessity was revealing truths that peacetime tradition had obscured. The woman who had stood before a disciplinary board facing termination in May became the subject of a War Production Board training film in July, demonstrating her technique for welders across America. Rose's story, however, was not unique at Richmond. Across Kaiser's 7 shipyards, similar transformations were occurring daily as workers unburdened by tradition discovered improvements that experts had missed. A former truck driver developed a crane signaling system that cut lifting operations time by 40%. A mathematics teacher created a template system that reduced measuring errors and eliminated most fitting adjustments. A grocery store manager redesigned parts staging that cut workers' walking distance by 60% and reduced time spent searching for components. The common thread connecting these innovations was not technical expertise or engineering education. The common thread was fresh perspective. Workers who had never built ships did not know what was supposed to be impossible. They approached each task as a problem to be solved, rather than a tradition to be honored. When solutions they discovered violated established practice, they questioned the practice, rather than abandoning the solution. This democratization of innovation, this proof that ordinary people could improve on expert systems, represented a philosophical revolution, as significant as the Industrial Revolution occurring in the yards. For centuries, Skilled crafts had been controlled by guild systems that restricted knowledge and protected masters' authority. Apprentices learned by observing and obeying, not by questioning or innovating. The suggestion that a novice might improve on a master's technique would have been considered not merely wrong but offensive, a violation of the natural order that governed skilled work. Kaiser's shipyards demolished that order completely. The former seamstress improved welding, the truck driver improved crane operations, the teacher improved measuring, the grocery manager improved logistics, and each improvement validated the revolutionary premise that human potential exceeded the boundaries that tradition had imposed on it. The ships rising on Richmond's building ways were not merely transportation vessels, they were proof that ordinary people, given opportunity and freed from constraining assumptions, could achieve extraordinary results. The summer of 1942 brought a new challenge that would test whether Rose Kramer's innovations represented isolated success or something more profound. The Maritime Commission, convinced by Richmond's productivity gains, issued a directive that seemed simple on paper, but carried enormous implications. All Liberty ship construction would transition to predominantly welded assembly, eliminating riveting except in specific applications where welding was mechanically impracticable. Traditional shipyards that had spent generations perfecting rivet-based construction would need to retrain their entire workforce in welding techniques within 60 days. The scale of this transformation was staggering. Approximately 18 shipyards across America were building Liberty ships under Maritime Commission contracts. These yards employed roughly 120,000 workers, most of whom had learned shipbuilding through traditional methods that emphasized riveting as the fundamental joining technique. The Commission's directive meant that over 80,000 workers would need retraining in welding, and the training would need to produce workers capable of matching Richmond's quality and productivity standards. The maritime establishment's response revealed the depth of their resistance to the changes Kaiser's operation represented. The president of Bethlehem Steel Corporation's shipbuilding division, a man named Howard Mackenzie, whose family had built ships in America since 1796, sent a formal protest to the Maritime Commission that was marked confidential but later declassified. His letter captured the traditional builders' fundamental objection to what they considered industrial vandalism disguised as innovation. Richmond's approach treats shipbuilding as if it were automobile assembly, interchangeable parts joined by semi-skilled workers following simplified procedures. This fundamentally misunderstands what ships are and why they require craft expertise. Every vessel encounters unique stresses. Every hull responds differently to sea conditions. The judgment that experienced shipwrights bring to their work cannot be replaced by standardized techniques performed by workers who learned their trade in weeks. Richmond's ships may appear adequate in calm harbors, but the North Atlantic will reveal the consequences of replacing craftsmanship with speed. Yet, even as Mackenzie wrote those words, ships built using Richmond's techniques were already crossing the North Atlantic in convoy operations, carrying ammunition, tanks, islands and supplies to Britain and North Africa. The first Liberty ships, launched from Kaiser's yards in late 1941, were now 9 months into service, and the catastrophic failures that traditional builders predicted had not materialized. The ships were not beautiful. They were blunt-bowed, slab-sided vessels that looked crude compared to the elegant designs traditional yards produced. But they floated, they carried cargo, and they survived the storms and submarines that characterized Atlantic crossings in 1942. Rose Kramer became central to the Maritime Commission's training expansion in an unexpected way. The War Production Board, recognizing that training films could accelerate skill development across the industry, selected Rose as the subject of a comprehensive instructional documentary. The choice was deliberate and calculated. Rose was not merely an effective welder. She was a symbol of the workforce transformation that was making American industrial mobilization possible. A woman, a former civilian with no maritime background, who had not only mastered but improved upon techniques that male craftsmen had practiced for generations. The filming occurred over 3 days in July at Richmond Yard No. 2. Rose demonstrated her single-pass technique on camera, while narration explained the specific parameters: electrode angle, arc length, travel speed, and amperage settings. but the film's deeper message transcended technical instruction. The opening sequence showed Rose arriving at the yard in work clothes, her welding hood under one arm, joining thousands of other workers streaming through the gates at shift change. The narrator's words, delivered in the measured tones characteristic of wartime documentaries, carried unmistakable subtext about who could contribute to national defense. This is Rose Kramer, a welder at Permanente Metals Corporation in Richmond, California. 9 months ago, Rose was a seamstress. Today, she welds structural components for Liberty ships that will carry supplies to our twelfth fighting forces overseas. Rose represents thousands of American women and men who have entered shipyards, aircraft factories, and munitions plants since Pearl Harbor. Workers who did not know they possessed industrial capability until their country needed them to discover it. The film was distributed to shipyards, technical schools, and training centers across America in August 1942. Its impact extended beyond welding instruction. The image of a woman performing work that had been exclusively male for centuries challenged assumptions about gender roles that would persist for decades after the war ended. More immediately, the film validated the Maritime Commission's decision to embrace rapid training over traditional apprenticeship. If Rose Kramer could become an expert welder in weeks, then the crash training programs being implemented industry-wide might actually work. But Rose's celebrity, such as it was, created unexpected complications. Other welders at Richmond, particularly men who had worked in traditional shipyards before joining Kaiser's operation, resented what they considered undeserved attention given to someone whose innovations they viewed as minor modifications rather than revolutionary breakthroughs. The tension came to a head in August, when a group of welders on Building Way No. 7 submitted a formal complaint to yard management, arguing that the Kramer method was being imposed unnecessarily on applications where traditional multi-pass welding was more appropriate. The complaint revealed a deeper conflict between two philosophies of work. The traditional welders believed that craftsmanship required comprehensive knowledge and judgment about when to apply different techniques. They argued that Rose's single-pass method was effective for the specific bulkhead seams she had been assigned but was not universally superior. Mandating it for all applications eliminated the welder's professional judgment and reduced skilled workers to mechanical repetition. This de-skilling of craft work, they argued, would ultimately degrade American shipbuilding capability, even as it temporarily increased production speed. Thomas Chen, now promoted to production superintendent for Richmond's 7 building ways, faced a dilemma that encapsulated the broader tension between craft tradition and industrial efficiency. He recognized that the traditional welder's concerns had merit. Not every welding application was identical, and experienced judgment about when to modify techniques was valuable. Yet he also recognized that the Maritime Commission's training directive assumed standardized procedures that semi-skilled workers could follow reliably. Allowing welders to exercise individual judgment about technique meant accepting variation in quality and productivity that wartime schedules could not accommodate. Chen's solution demonstrated the pragmatic flexibility that characterized Kaiser's management approach. He created 2 welder classifications, Standard and Master. Standard welders, who comprised about 85% of the workforce, would follow prescribed techniques for specific applications, including the Kramer method for bulkhead seams. Master welders, selected from workers who demonstrated both exceptional skill and sound judgment, would be authorized to modify techniques based on their assessment of specific conditions. This preserved craft expertise while ensuring that the majority of work followed proven procedures that even novice welders could execute reliably. The classification system resolved the immediate dispute, but it also revealed something profound about how industrial work was being transformed. Before Kaiser's shipyards, there had been only one kind of shipyard welder, the trained craftsman who understood welding comprehensively and could adapt to any situation. Kaiser's operation had created something new, the specialized operator who mastered specific techniques for specific applications and performed them repeatedly without variation. This was not traditional craftsmanship, but neither was it mindless repetition. It was a new category of skilled work that borrowed from both craft tradition and assembly line efficiency. Rose herself viewed the controversy with bemused detachment. She had not sought attention or celebrity. She had simply tried to do her assigned work as effectively as possible, and had discovered improvements through systematic experimentation. The fact that her improvements challenged traditional practice was incidental to her purpose. She was not interested in revolutionizing shipbuilding. She was interested in contributing to the war effort and earning wages that were triple what garment work had paid. Yet Rose's personal modesty could not diminish the significance of what her example represented. By September 1942, over 15,000 women were working in Kaiser's 7 shipyards, representing approximately 8% of total employment. These women were not confined to clerical or support roles. They were welding, fitting, crane operating, and performing every job that men performed, except those requiring physical strength that exceeded typical female capability. The presence of women in skilled industrial positions was not merely symbolic, it was mathematical necessity. The draft was consuming American manpower at a rate that would have made industrial mobilization impossible if factories and shipyards had remained limited to male workers. By the end of 1942, over 3 million American men would be in uniform, a number that would triple by 1944. The industrial workforce required to supply those forces exceeded the available male population by millions. Women entering factories was not progressive social policy. It was unavoidable demographic reality. The only question was whether industries would embrace female workers enthusiastically or reluctantly. Kaiser's yards embraced them enthusiastically, not from ideological commitment to gender equality, but from practical recognition that productivity mattered more than tradition. The yards needed welders, and Rose Kramer had proven that women could weld as effectively as men. The yards needed crane operators, and female operators were demonstrating equal competence to male counterparts. The yards needed every kind of industrial worker, and gender was irrelevant to ability to perform the work. This pragmatic acceptance of female capability, however motivated by necessity rather than principle, opened opportunities that would have been unthinkable in peacetime America. The ripple effects extended into Richmond's community in ways that transcended employment statistics. Women earning 75 cents per hour in shipyard work possessed economic independence that fundamentally altered household dynamics and social relationships. A female welder earning $30 per week made significantly more than her husband might earn in many civilian occupations. This economic inversion of traditional gender roles created both opportunities and tensions that would influence American society for decades. Rose experienced this personally when her husband James, who worked as a clerk in a downtown San Francisco office, quit his job in October 1942 to enroll in welding training at Richmond. His decision was partly economic. The shipyard paid better, but it was also psychological. Having his wife earn double his salary while performing work that required obvious skill and courage created a dynamic that challenged his self-conception as family provider. By becoming a welder himself, James could reclaim some traditional masculine identity while also contributing more substantially to household income and war effort. The Kramers' experience was replicated in thousands of families across Richmond, Portland, and Vancouver, where Kaiser's yards operated. Marriages strained and sometimes dissolved under the pressure of reversed economic roles. Other marriages strengthened as couples discovered partnership based on mutual contribution rather than hierarchical gender expectations. Children growing up in shipyard communities during wartime witnessed their mothers performing work that peacetime culture had defined as impossible for women, a lesson about capability and possibility that would shape the generation that came of age in the 1950s and 60s. By late 1942, the transformation of American shipbuilding was approaching completion. The Maritime Commission's August directive requiring transition to welded construction had been implemented across the industry, often reluctantly, but ultimately successfully. Average Liberty ship construction time across all 18 building yards had fallen from 230 days initially to 90 days by October. Kaiser's yards were averaging 62 days, nearly 30% faster than the industry standard they had created. The productivity improvements were not limited to welding. Every aspect of ship construction was being revolutionized through systematic analysis and experimentation. The prefabrication approach that Kaiser had pioneered was now industry standard. Building ways that had once constructed ships from keel to deck sequentially now assembled prefabricated sections in parallel. Components that traditional yards built on site were now manufactured in specialized facilities and delivered ready for installation. The entire conceptual framework of ship construction had shifted from custom fabrication to modular assembly. Rose's contribution to this transformation was simultaneously crucial and limited. Her welding innovation had accelerated one critical process and had demonstrated that untrained workers could improve expert techniques. But her deeper significance was symbolic. She represented the democratization of capability that was making American industrial mobilization possible. The Maritime Commission's training films featured Rose, but they could have featured dozens of other workers whose innovations and productivity were equally impressive. Rose became famous because her story captured something the nation needed to believe about itself, that ordinary Americans possessed extraordinary potential that would be revealed when their country needed them. The autumn of 1942 brought a development that would cement Rose's place in shipbuilding history while simultaneously revealing the limitations of individual innovation. Kaiser's Richmond yards were preparing to attempt the construction challenge that would produce the SS Robert E. Peary, the ship built in 4 days and 15 hours that would become the most celebrated demonstration of American industrial capability. Rose was selected as one of 60 lead welders who would supervise the prefabrication and assembly teams during the record attempt. The selection was both honor and burden. Rose would be responsible for ensuring that every vertical bulkhead seam met quality standards while maintaining the extraordinary pace required to complete the ship in under 1 week. A single structural failure during sea trials would discredit not only the speed record, but also the entire rapid training philosophy that Rose's success had helped validate. The pressure was immense, the scrutiny overwhelming, and the consequences of failure potentially catastrophic for both Rose personally and for the thousands of female workers whose opportunities depended on continued confidence in women's industrial capability. The week of the Robert E. Peary construction, scheduled for early November, would test whether the innovations that individuals like Rose had developed could be scaled and coordinated into systematic industrial achievement. It was one thing for a single welder to improve productivity on routine assignments. It was something entirely different to coordinate hundreds of workers, each performing specialized tasks, into an integrated operation that would complete a complex vessel in 1/10 the normal time. The difference between individual capability and organizational capability would determine whether American industrial mobilization could actually deliver the production volume that Allied victory required. As Rose prepared for the record attempt, she understood that she was no longer welding simply for herself or even for her immediate work crew. She was welding for every woman who had entered industrial work since Pearl Harbor, for every worker who had been told their background made them unsuitable for skilled trades, and for every American who needed to believe that their country possessed industrial strength sufficient to win a global war against enemies who had been preparing for years. The welds Rose would create during that November week would carry more than structural loads. They would carry the weight of proof that democracy's industrial capacity could overwhelm dictatorship's military preparation. The woman who had stood before a disciplinary board 6 months earlier, accused of illegal technique, was now being asked to stake her reputation and her country's credibility on those same techniques. The transformation from accused violator to celebrated innovator to national symbol had occurred in less than 1 year, a trajectory that captured both the opportunity and the burden that wartime emergency created for ordinary Americans who found themselves doing extraordinary things. November 8, 1942 arrived with overcast skies and temperatures barely above 40 degrees Fahrenheit. At 1 minute past midnight, Rose Kramer joined over 1,000 workers gathering at Richmond Yard No. 2 for the beginning of what would become the most scrutinized ship construction in American history. The SS Robert E. Peary would be built from keel laying to launch in less than 1 week if everything proceeded according to plan. For Rose and the 59 other lead welders assembled in the pre-dawn darkness, The plan represented both opportunity and vulnerability on a scale none of them had imagined when they entered shipyard work. The prefabrication strategy that would make the record attempt possible had been developing for months. Unlike normal Liberty ship construction, where major components were fabricated and assembled concurrently over several weeks, the Peary's components had been built, inspected, and staged before the official construction clock started. The bow section, weighing over 100 tons, sat on railroad flat cars 50 yards from building way number 2. The stern assembly, equally massive, waited on parallel tracks. 4 complete cargo holds, each a rectangular steel structure 30 feet long and 25 feet wide, were positioned for crane installation. The engine, a 140-ton triple expansion steam plant, had been mounted on its foundation and tested at the manufacturer's facility in Sunnyvale before being transported to Richmond. What made this prefabrication different from normal practice was completeness. Conventional prefabrication created major sections that would be joined and then outfitted with equipment, piping, electrical systems, and interior fittings over subsequent weeks. The Peary's sections were 90% complete before touching the building way. The bow section included installed anchor hardware, chain lockers, windlass machinery, and forward crew quarters complete with bunks and plumbing. The stern section contained the steering gear, propeller shaft, rudder assembly, and aft crew spaces fully outfitted. This was not shipbuilding as the industry had understood it. This was ship assembly, treating a complex ocean-going vessel as if it were a piece of furniture delivered in flat-pack form. Rose's assignment placed her with a team of 12 welders responsible for joining the forward cargo holds to the main deck structure. The work would occur on the second day of construction, after the keel, bottom plates, and lower hull sections had been assembled. The team would work from scaffolding platforms positioned around the hull, welding the massive cargo hold assemblies to the deck beams and bulkhead plates. Each hold required approximately 200 vertical seams connecting the hold's outer walls to the ship's internal structure. Rose would supervise while also performing the most critical welds, where structural integrity was essential. The first 24 hours of construction established whether the ambitious timeline was achievable or fantastical. The keel, a massive steel beam 441 feet long, was positioned on the building way at 12:03 in the morning of November 8th. By 6 o'clock that same morning, the bottom plates forming the ship's lowest hull section were being welded to the keel. By noon, the first bulkhead sections were being lifted by crane and positioned for welding. By 6 o'clock that evening, the lower hull was recognizably ship-shaped, a long steel structure that bore no resemblance to the scattered components that had existed 18 hours earlier. Rose watched the first day's progress with growing confidence mixed with increasing awareness of how many things could still go wrong. The precision required for successful modular assembly was extraordinary. If prefabricated sections did not align within fractions of an inch, welders would waste hours grinding, cutting, and fitting pieces that should have joined immediately. If quality inspection revealed defects in critical welds, entire sections might need to be removed and reworked. If crane operations experienced delays or accidents, the carefully choreographed sequence of installations would be disrupted with cascading effects on every subsequent operation. The second day brought Rose's team into action. At 7 o'clock on the morning of November 9th, the first cargo hold assembly, a rectangular steel structure weighing 68 tons, was lifted by overhead crane and slowly lowered into position in the forward section of the ship. Rose and her 11 welders were positioned on scaffolding platforms surrounding the installation point before the hold arrived. The moment the hold settled into place, supported temporarily by wooden bracing, the welders moved in. Rose took the forward starboard corner, the most visible position and the one whose welds would be inspected first. The technique Rose employed was the single-pass method she had developed 9 months earlier, now refined through thousands of repetitions. Her torch moved in smooth vertical strokes, the electrode maintaining precise distance from the workpiece, the molten metal flowing into the joint between cargo hold wall and deck beam. The bead she created was not beautiful by traditional standards. It lacked the neat, uniform appearance that master craftsmen produced with multiple passes and careful finishing, but it penetrated deeply into both pieces of metal, creating fusion that exceeded the strength of the surrounding material. Within 45 minutes, Rose's corner was complete. The quality inspector, a former high school physics teacher named Margaret Chen, who had been trained in weld evaluation just 3 months earlier, examined the seams with practiced eye. She checked for porosity, cracks, undercut, and excessive penetration. She verified that the bead fully covered the joint without gaps or inconsistencies. She measured the bead width to ensure it met minimum specifications. Every seam passed. Rose's work was approved, and she moved to the next position while her team completed their assigned sections. By 6 o'clock that evening, all 4 cargo holds were installed and welded in place. The ship now had its basic internal structure: keel, bottom plates, hull sides, bulkheads, cargo holds, and main deck. What remained was the superstructure, the deck houses containing crew quarters and navigation bridge, and the final installation of the engine and propulsion system. The timeline showed 42 hours elapsed since construction began. The ship was approximately 55% complete. The pace was extraordinary, but it was also revealing stresses in the system that normal construction schedules could absorb, but compressed timelines could not. The third day brought the first serious crisis. The engine installation, scheduled to begin at 6 o'clock on the morning of November 10th, was delayed when crane operators discovered that the engine's mounting foundation did not align properly with the engine room structure. The misalignment was slight, less than 2 inches, but it was sufficient to prevent the engine from being lowered into position. The construction schedule had no margin for delays. Every hour lost would need to be recovered through faster work on subsequent operations, or the record attempt would fail. Thomas Chen, supervising the entire construction as production superintendent, faced an immediate decision. The proper solution was to cut away portions of the engine room structure, reposition the mounting foundation, and re-weld everything with precision. This would take approximately 8 hours and would require removing workers from other tasks to concentrate on the problem. The alternative was to modify the engine mounting system itself, adding shims and adjustment plates that would correct the misalignment without modifying the ship's structure. This was faster but less elegant and would create a permanent mechanical compromise in the engine installation. Chen chose speed over perfection. The engine mounting was modified with steel shim plates and additional bracing, and by 2 o'clock that afternoon, the massive power plant was being lowered into the engine room. Rose watched the operation from the main deck, understanding that the decision Chen had made represented everything that traditional shipbuilders feared about rapid construction. Compromises and workarounds were being accepted that conventional practice would reject. The ship was being built to adequate standards rather than optimal standards, and nobody could be certain whether adequate would prove sufficient when the vessel encountered heavy seas. Yet Rose also recognized that the alternative to adequate ships built quickly was perfect ships built slowly, and slowly meant that Allied shipping losses would exceed replacement capacity. Mathematics did not care about elegance. The war would be won or lost based on tonnage delivered, and tonnage delivered depended on ships completed, not ships perfected. The engine installation that Chen approved in 2 hours using shimmed mounting would serve the same function as an installation requiring 8 hours of structural modification. The ship would sail either way, and sailing 8 hours sooner meant cargo delivered 8 hours earlier. The 4th day of construction, November 11th, was Armistice Day, commemorating the end of the First World War 24 years earlier. Many shipyards observed the holiday with reduced shifts and patriotic ceremonies. Richmond Yard No. 2 maintained full production schedules, with workers understanding that the best way to honor those who had fought in the previous war was to build ships that would help win the current one. By noon on November 11th, the superstructure was complete, the deck houses were installed, and the ship looked finished from external appearance. What remained was primarily internal work, completing electrical systems, installing pumps and piping, mounting navigation equipment, and conducting initial tests of critical systems. Rose's involvement in the construction was essentially complete by mid-afternoon of the 4th day. Her team had welded every major structural joint in the forward section of the ship, and quality inspection had approved every seam. She had performed her specific role in the larger orchestration flawlessly, and now she could only watch as other specialists completed their portions of the vessel. The experience gave Rose perspective on what had been accomplished. She was an excellent welder, yes, and her technique had contributed to the ship's rapid completion, but she was also one of over 1,000 workers whose coordinated efforts had transformed scattered steel components into a functional ship in less than 100 hours. The realization was simultaneously humbling and empowering. Rose's individual contribution was necessary, but not sufficient. The record would be achieved not because of any single person's brilliance, but because of systematic organization that allowed hundreds of specialized workers to contribute their specific capabilities in coordinated sequence. This was the deeper revolution that Kaiser's shipyards represented. Industrial success no longer depended on a few master craftsmen whose comprehensive knowledge made them irreplaceable. Industrial success now depended on organizational systems that allowed many workers with limited, specialized knowledge to collectively achieve results that exceeded what master craftsmen could accomplish individually. November 12th arrived with clear skies and unusual warmth for mid-autumn. At 3:30 in the afternoon, precisely 4 days, 15 hours, and 29 minutes after construction began, the SS Robert E. Peary slid down the launching rails into San Francisco Bay. The crowd gathered to witness the launch included Vice Admiral Emory Land, chairman of the Maritime Commission, along with dozens of journalists, maritime officials, and representatives from competing shipyards. Many had arrived skeptical, expecting either that the ship would not be completed on schedule or that it would be a barely functional shell requiring weeks of additional work before entering service. What they witnessed, instead, was a complete operational vessel that required only minor finishing work before being delivered to the Warshipping Administration. The ship had functioning engines, operating electrical systems, equipped crew quarters, and installed navigation equipment. It could theoretically have put to sea that day if stores and fuel had been loaded. The completion was not perfect by peacetime standards, but it was entirely adequate for wartime necessity, and adequate accomplished in 5 days exceeded perfect accomplished in 5 months. Vice Admiral Land's remarks at the launching ceremony were recorded by newsreel cameras and broadcast in theaters across America. His words revealed the maritime establishment's forced recognition that industrial war required abandoning assumptions that had governed shipbuilding for millennia. The admiral who had initially resisted Kaiser's unorthodox approaches now acknowledged that orthodox approaches had been insufficient. What we have witnessed here challenges everything I learned in 35 years of naval service. Traditional wisdom said you cannot build a proper ship in less than 6 months. Henry Kaiser and his workers have made that wisdom obsolete. More importantly, they have demonstrated that American industrial capacity, properly organized and courageously led, exceeds any limit our enemies might imagine. The ships built in these yards will carry the supplies our forces need to win this war. The techniques developed here will influence shipbuilding worldwide for generations to come. For Rose Kramer, standing with her welding crew among the 1,000 workers who had built the ship, the Admiral's words carried personal validation that transcended the specific achievement. 9 months earlier, she had been a seamstress whose capabilities were limited by social expectations and economic circumstances. Today she was a lead welder whose techniques had been documented in training films and whose work had contributed to the most celebrated shipbuilding achievement in American history. The transformation had occurred not because Rose possessed extraordinary talent, but because extraordinary circumstances had created opportunity for ordinary talent to be discovered and developed. The weeks following the Robert E. Peary launch brought both celebration and sobering reality. The ship's record construction time was extensively publicized as demonstration of American industrial might. Newspapers across the country ran stories about the 4-day ship, often featuring photographs of female welders, including Rose. The publicity served important propaganda purposes, reassuring Americans that their country possessed industrial capacity to defeat enemies who had been preparing for war much longer. But the publicity also created pressures that complicated the real work of sustaining high-volume production. Kaiser's yards did not attempt to replicate the Peary record. The extreme prefabrication and compressed timeline had been possible only by dedicating enormous resources to a single ship, resources that normal production could not sustain. Richmond Yard No. 2 returned to building Liberty ships in 60 to 70 days, using the standard prefabrication approach that had been developed over the previous year. This pace, while far slower than the Peary's record, represented the sustainable productivity that would actually win the war through accumulated volume rather than spectacular individual achievements. Rose continued welding through 1943 and into 1944, her work routine and unremarkable after the brief celebrity of the record ship. She trained new welders as they arrived, passing on the techniques she had developed and refined. She welded structural seams on dozens of ships whose names she never learned and whose ultimate fates she would never know. The work was demanding, dangerous, and sometimes monotonous, but it was also meaningful in ways that seamstress work had never been. Every ship Rose helped build would carry cargo that might determine whether soldiers survived or starved, whether battles were won or lost, whether the war ended sooner or dragged on longer. By late 1944, the tide of war had turned decisively. Allied shipping losses were declining as improved convoy tactics and air coverage reduced submarine effectiveness. American ship production had so exceeded losses that the War Shipping Administration was actually accumulating surplus vessels. The Maritime Commission began reducing construction contracts in anticipation of war's end. Richmond's workforce, which had peaked at over 100,000 in early 1944, began declining as workers left for other opportunities or returned to pre-war occupations. Rose Kramer left Richmond shipyard in March 1945, 3 months before the final Liberty ship was launched from the facility. Her departure was unremarkable, processed through the same administrative procedures that handled thousands of other separations as the yards wound down operations. She received no special recognition beyond the standard certificate of appreciation given to all departing workers. Her personnel file, preserved in National Archives records, contained performance evaluations, noting excellent productivity and quality, but no indication that she had once been featured in training films or had developed techniques that influenced shipbuilding practice across the industry. The anonymity of Rose's departure captured something profound about the workforce that had built America's wartime maritime fleet. They were ordinary people who had achieved extraordinary results, not through individual heroism, but through collective effort sustained over years. Their names were forgotten, their specific contributions unrecorded, but their collective achievement remained visible in the statistics that documented American industrial mobilization. Over 2,700 Liberty ships built between 1941 and 1945, representing approximately 19 million tons of shipping. Over 5,500 total vessels, including Liberty ships, Victory ships, and other classes, totaling approximately 53 million tons. These numbers represented not steel and machinery, but human effort, millions of workers who had welded, fitted, painted, and assembled the physical infrastructure of Allied victory. Rose returned to San Francisco in spring 1945 and found work in a commercial laundry, the shipyard wages and opportunities having evaporated with the end of hostilities. She never welded again. The skills she had developed over 3 years of intensive practice were allowed to atrophy because peacetime industry had no place for female welders. The training films that featured her were archived and forgotten. The innovations she had contributed were absorbed into standard practice without attribution. By 1950, Rose Kramer was again a low-wage service worker, indistinguishable from millions of other women whose wartime industrial experience was dismissed as temporary necessity rather than recognized as demonstrated capability. Yet the significance of Rose's story and the stories of thousands like her could not be erased by peacetime neglect. They had proven that ordinary people possessed capabilities that peacetime society refused to acknowledge. They had demonstrated that complex industrial work could be mastered quickly when necessity demanded it. They had shown that traditions limiting who could perform skilled labor were social constructions rather than natural limitations. These lessons would influence the generations that followed, slowly eroding the barriers that had confined women and minorities to restricted economic roles. The welding technique that Rose developed lived on in maritime practice long after Rose herself was forgotten. The single pass, heavy penetration method for bulkhead seams became standard procedure in modular ship construction worldwide. Japanese and Korean shipyards, building the massive vessels that would dominate global shipping in the late 20th century, used approaches directly descended from the techniques Rose had innovated and refined in Richmond during 1942. The ships themselves, those thousands of Liberty vessels built during the war, served far longer than their designed 5-year lifespan suggested. Many operated commercially into the 1970s, carrying cargo 3 decades after construction. The woman who had stood before a disciplinary board accused of illegal technique in May 1942 had contributed something more valuable than any individual ship. She had demonstrated that innovation could come from unexpected sources, that authorities' claims about what was possible or proper were often wrong, and that ordinary capability could produce extraordinary results when given opportunity. These truths, proven in the shipyards and factories of America's wartime industrial mobilization, would echo through decades of subsequent social and economic change. The revolution that Rose Kramer participated in was not completed in her lifetime. The barriers that confined women and minorities to restricted roles were not eliminated by wartime necessity, but those barriers were weakened, their arbitrary nature exposed, and the generations that followed would build on foundations that workers like Rose had established through their simple insistence on attempting what authority claimed was impossible. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.